Welcome back. In our previous sessions, we have discussed about IP addressing and its types, classes of IPv4, and a brief overview about IPv6. In today's session, we are going to discuss about subnet mask, network IDs, broadcast IDs, and how system identify to which network a particular IP address belongs to. As a human, on seeing an IP address in decimal format, we can judge which class it belongs to. But system does not have any parameters to identify that. Subnet mask helps to identify the network of a particular IP address. It defines the boundary of a network, that is, the range of the entire network. For example, if I consider an IP address of it belonging to 10 network, it ranges from 10.0.0.0 to 10.255.255.255. This boundary is defined by subnet mask. The subnet mask is also of 32-bit length and is formed by placing ones in network portion and zeros in the host portion. The ones and zeros are in binary but not in decimal. That is, the subnet mask is separating the network part and host part. Network ID. Network ID is the leader for the network range. It is used to represent the entire range and it is the first IP address of the network range. It is formed by keeping zeros in the host portion without disturbing the network portion. For example, consider an IP address 10.0.0.1. It belongs to class A. That is, the first octet is network portion and remaining 24 bits or 3 octets are host portion. So the network ID of 10.0.0.1 IP address is formed by keeping zeros in the host portion and not disturbing network portion. Here 10 belongs to the network portion, so it is not disturbed, and remaining 24 bits belongs to the host portion. That is why we are placing 24 zeros in the host portion. So the actual network ID will be 10.0.0.0. For any IP address starting with 10.0.0.0 to 10.255.255.255, the network ID will be 10.0.0.0. Broadcast ID. If you want to send a message to all the systems present in the network, you can just send it to a broadcast IP address. It takes care of sending the data to all the PCs connected in that network. The broadcast ID is formed by placing ones in the host portion without disturbing network portion. For the same example, that is 10.0.0.1, the broadcast ID will be 10.255.255.255. The 255s represent all ones. And as 10 is the network portion, it is not disturbed. So for any IP address between 10.0.0.0 to 10.255.255.255, the network ID and broadcast ID will be 10.0.0.0 and 10.255.255.255. The network ID and the broadcast ID cannot be assigned to any PC because they are used for special purposes. The network ID represents the entire network, whereas broadcast helps to send the same message to the entire network. The default subnet mask for class A, B, and C are as shown here. For class A, it is 255.0.0.0. The first octet of class A is a network portion. The subnet mask is formed by placing ones in the network portion. That is, 8 ones are placed in the network portion, which is equivalent to 255. Whereas remaining 3 octets belongs to the host portion. That is why they are replaced with zeros, which means that the default subnet mask for class A will be 255.0.0.0. Coming to class B, there are 16 bits, that is 2 octets in the network portion. So the subnet mask will be 255.255.0.0. Similarly for class C, it is 255, 255, 255.0. And class D, you can represent it with the subnet mask all 255s, that is 32 ones. The system performs ending operation between subnet mask and the IP address to find the network ID. The process of finding the network ID is known as masking. Consider the IP address 10.0.0.1. Just by seeing the IP address 10.0.0.1, we can say that it belongs to 10 network and its network ID is 10.0.0.0 and its broadcast ID is 10.255.255.255. But how does the system identifies the network ID? it performs the masking operation. That is, it performs a logical AND between the IP address and its subnet mask. The 10.0.0.1 is converted into binary, and the binary representation is equal to 4 zeros 1010, and remaining 23 bits will be 0 and the least significant bit will be 1. The default subnet mask for class A is 255.0.0.0, and it's represented in binary as 81.80.80.80. Masking is done by performing bitwise AND operation on IP address and the subnet mask. First, the IP address and subnet mask are converted into binary, and a bit by bit AND operation is done on them. The output of the AND gate will be 1 only if the IP address and the subnet mask bits are 1, else the output will be 0. Here in our case, the IP address and the subnet mask bits are 1 for the fifth position from MSB, that is most significant bit. That is, the output will be 1 in the fifth position and also in the seventh position, because there is 1 in the IP address and even in the subnet mask. And remaining bits will be 0 because there are no ones there. Hence, the network ID formed will be 4 zeros, 1010, and 24 zeros, whose decimal equivalent is 10.0.0.0, that is our network ID. This is how the system identifies the network ID. The network ID is used to represent the entire network, and the network ID will be handy when we are performing the routing operations. Instead of the router saying the other routers that I know 10.0.0.1, 10.0.0.2, so on to 10.255.255.254, it simply says that I know the entire 10 network by sending a message to the routers that it knows 10.0.0.0. This is in brief about masking, subnet mask, network ID, and host IDs. That's all for this session.